All right, here we have the equation or function x squared minus 8x plus 15. And the first thing we want to do is we want to put the equation in factored form. So we want to ask ourselves what multiplies to 15 but adds to negative 8? Well, I see that I can break this up into 3 and 5. And if I make them both negative, negative 3 times negative 5 is going to give me positive 15. And negative 3 plus negative 5 is going to give me the negative 8. Therefore, I know that the equation in factored form will be x take away 3 times x take away 5. From here, I can find my x-intercepts very easily, okay? My x-intercepts are going to be when I solve the equation. So let's erase some of the work I did. Actually, let's not erase. Let's just rewrite it. So we know we have, and look down on the bottom left, we have x minus 3 times x minus 5. If we want to find the x-intercept, set it equal to 0, and you will get x is equal to 3 and x is equal to 5. Those are your x-intercepts, 3, 0, and 5, 0. So let's graph those. 3, 0, 5, 0. Okay. The y-intercept is when x is 0. So we're going to say that we have 0 squared minus 8 times 0 plus 15. And we will see that we have a y-intercept at the point 0. I'll just write 15 here. 0, 15. So let's graph that point. All right. Now, point symmetric to the y-intercept. Well, we have to think about this. How would we know that unless we know where our axis of symmetry is? And I think our axis of symmetry we can see is right here. Okay, so if I draw this line all the way up, well, how many units away is it? It's 1, 2, 3, 4. So 1, 2, 3, 4 puts me at the point 8, 15. All right, what is the leading coefficient? Well, the coefficient is the A value. So here, I can't get my pen to work all of a sudden. So here our A value is 1. So our leading coefficient is 1. All right, our axis of symmetry is going to be at x equals 4. You can see that right here. I know you can't see the 4, but that's where the line is. All right, which way does it open? Well, let's think about graphing this. If we were to graph this, we would see that it would look something like this here, okay? So because of that, we know that it opens up. All right, is the vertex represent a minimum or a max? Here it is a min. Okay, where is our vertex? Well, we know our vertex is when x equals 4. So let's figure it out. We're going to have 4 squared minus 8 times 4 plus 15, which is going to give us 16 minus 32 plus 15. So 16 minus 32 is negative 16, plus 15 will give us negative 1. So we have a vertex at, so I can change or fix my graph a little bit here, because I know now that it's at negative 1, which is here. So this is exactly what my graph should look like. Okay. And that was our vertex again, right here. All right. Now, increasing and decreasing intervals. Well, it is increasing. Again, won't write for whatever reason. It is increasing from our vertex at negative 1 all the way up to infinity. It is decreasing from negative infinity down to our negative 1. All right, what is our average rate of change over the intervals given? Well, let's see, from 4 to 5. So x equals 4 here to 5, I would go up 1 over 1, so it would be 1 over 1. From 5 to 6, well, it looks like 6 is at 2. Let's do that really. 36 minus 48, 12. I believe it's supposed to actually be at 3. We're going to say 3. So we're going to go up 3 over 1. And then from 6 to 7, so we're going to put our answer here. Well, if 6 is at 3, and we know 7 is going to be at, let's see, what's 7 going to be at? 7 squared is 49. 49 minus 56 is negative 7. So that's going to go to 8. So we're going to go up 5 over 1.